Alright guys, you made it to my second video on solving equations, and this time I'm going to be focusing on showing you how to solve rational equations in 5 steps or less. Hey guys, and welcome back. Welcome to the game, and as you know, the goal here is to free the variable x by any means necessary, and the golden rule is whatever you do on one side, you do on the other. We're going to be focusing this time on solving logical equations in 5 steps or less. So let me go ahead and give you what the 5 steps are. Number 1 is going to be for you to factor the numerator and denominator. Number 2 is going to be for you to multiply by the LCD. Then number 3 is going to be to simplify. Number 4 is going to be to isolate the variable x. Then number 5, which is very important, is going to be for you to check the solution you found against the domain. Alright, so let's jump into some examples to see what I mean by that. The first example that we're going to have here is going to be 1 divided by x minus 1 plus 5 equals to 11 divided by x minus 1. And so as you can see here, there's nothing to factor because everything is already factored, so step 1 is done. Our least common denominator here, our LCD, is going to be simply x minus 1 because that's our common denominator here. So I'm just going to go ahead and multiply this whole equation by our LCD. So that's going to be multiply this whole thing by x minus 1. And so then I'm going to go in and simplify it a little bit. So that's going to be x minus 1 here divided by x minus 1 plus 5 times x minus 1 equals to 11 times x minus 1 divided by x minus 1. As you can see here, what I'm doing is multiplying every single term by the LCD. This is something you do every time you want to get rid of the denominator because you don't want to have the denominator when you're solving for something because that's just going to slow you down. And so let's simplify a little bit further here. So we're going to have x minus 1 and x minus 1 cancel, leaving you with just 1, plus 5x minus 5 equals to 11. So now we can go ahead and isolate our variable here. So we're going to subtract on both sides -1, and then add 5 on both sides as well. So that's going to finally give us 5x equals to 15, because 15 is 11 minus 1 plus 5. Last thing we need to do here to isolate the variable x is to divide both sides by 5. So I'm going to have x equals to 3. And then our very last step is to check the solution we just found here, x equals 3, against our domain. So if you remember how to find domain of rational equations, it's simply for you to make sure that whatever you found do not make the original equation's denominators 0, because dividing by 0 is something that's very much frowned upon in mathematics, so you don't do that. It doesn't exist. If you look up here, the denominators that we have here is just x minus 1, which means that we don't want x to be 1. And so since our solution 3 is not 1, then we can keep it, right? Because it's a good solution. So then, after checking like this, you are done. Let's look at another example here, example number 2. We are going to have 3 divided by 2x minus 2 plus 1/2 equals to 2 divided by x minus 2. First thing we need to do here is to factor everything. So if you look at our first term here, the denominator 2x minus 2 can be factored out because 2 is common to both of those terms. So you're going to have 3 divided by 2, open big parenthesis, x minus 1. The second term here, 1/2, cannot be factored, so it's going to be this. It's going to stay the same. And our last term here, 2 divided by x minus 1, is also all factored already, so we have to leave it that way. So after factoring like this, you can see that your LCD here, your least common denominator, has to at least include 2 and x minus 1. So I'm going to multiply both sides of the equation by 2 times x minus 1. And for doing that, I'm going to then simplify it by distributing this to all my terms. So I'm going to have 3 multiplied by 2 multiplied by x minus 1, all divided by 2 times x minus 1, plus 2 times x minus 1 divided by 2 equals to 2 times 2 times x minus 1 divided by x minus 1. Okay, so I'm going to go ahead and try to cancel everything that I can here. So 2 times x minus 1 here is gone, so I'm going to be left with just 3. And then our next one here, 2 and 2 is gone, so I'm going to have just x minus 1. Then x minus 1, and the other side here is gone, so I'm going to be left with just 2 times 2, which is 4. Next, I'm going to try to isolate the variable x by subtracting 3 on both sides of my equation and also adding 1 on both sides of my equation. So I'm going to have here just x is left, which is going to be equal to 4 minus 3, which is 1, plus 1, which is 2. So I'm going to have x equal 2 here. But before I'm done with this, before I celebrate, I have to go and check this solution against my domain. So if we look up here, if you look at our completely factored equation here, you can see that x here should not be equal to 1. And so since our x that we found is 2, not 1, then this x equals 2 is a perfect solution for this rational equation. And now we can celebrate. Boom. Okay, so let's look at more examples just to make this sink in. Example number 3 here, it's going to be 1 divided by x minus 3 minus 2 divided by x plus 1 equals to 8 divided by x squared minus 2x minus 3. Okay, so first thing first, let's go ahead and factor everything out. In our first term here, 1 divided by x minus 3 is already all factored, minus 2 divided by x plus 1 is already all factored, equals to, our last term here is not factored already, so we're going to have 8 on top, divided by, on the bottom here we have a quadratics, so we're looking for two numbers that are adding to negative 2 and multiplying to negative 3. And those numbers are going to be negative 3 and 1. So we're going to have here x minus 3 and x plus 1. We look at this and we see that our LCD need to at least include x minus 3 and x plus 1. And so we're going to multiply this entire equation by x minus 3 times x plus 1, which is going to give us, if we multiply it through, the first term here, x minus 3 is going to cancel out, so we're going to have only x plus 1 left. Next term, x plus 1 will cancel out, so we're going to have only negative 2 and x minus 3 left. In our last term here on the other side of the equation, both the denominators are going to get cancelled by our LCD, so we're going to be left with just 8. And so now we can go ahead and simplify it a little bit more. So we're going to have x plus 1 minus 2x plus 6 equals 8, right? So let's go ahead and subtract negative 1 on both sides and also subtract negative 6 on both sides. After we've done that, we're going to have x and negative 2x giving us negative x. And on the other side, we're going to have 8 minus 1 minus 6 giving us 1. Finally, divide both sides of this equation by negative 1, and you're going to get x equals negative 1. Last thing before we celebrate, let's go and check this particular solution against our domain. So if you look back at our completely factored rational equation here, we're going to see that we don't want x to be 3, and we don't want x to be negative 1. And so therefore, since our solution is negative 1, which is one of those numbers we don't want in our domain, we're going to get that this particular rational equation has no solution. And that will be done. So no solutions for this one, sadly. What this means basically is that in this equation that you have up here, this expression on the left and this expression on the right would never be equal to each other for any numbers. Let's look at our last example here. It's going to be an unusual one with many, many variables. So let's look at 1 divided by p plus 1 divided by q equals to 1 divided by f. And we are solving here for f. So we're going to do the same exact steps, right? Even though you have more than one variable here, you have to focus on f because you're solving for f, but the steps for solving any rational equations are going to be always the same. So we're just going to go ahead and factor every single term that we have But since all these are very simple, they already are factors, so we can move on to step number 2, which is to multiply this entire equation by the LCD. And as you can see here, the LCD has to at least include every denominator that we have. So we're going to have P, Q, F as our LCD. So multiplying this whole equation by P, Q, and F, we're going to have P, Q, F divided by P plus P, Q, F divided by Q equals PQF divided by F. And so now we can go ahead and just cancel out every single factor that happens on the denominator and the numerator. So on the first one here, P will be gone. So you're going to have Q and F left. The next one here, Q will be gone. So you're going to have P and F left. And then the next one here, F is gone. So you have P and Q left. Next thing to do is to simplify this particular thing. So we're going to realize that on the left side here, F is the variable that we're solving for, and it can be found in each of those particular terms. And so we're going to go ahead and factor it out. So we're going to have F, open big parenthesis, Q plus P equals to PQ. And last thing we need to do here is to divide both sides by Q plus P so that we can isolate F completely. And then we're going to have F equals to PQ divided by Q plus P. And just for good measure, we're going to say that this particular solution is ours as long as P, Q, and F are non-zero. Because if you look up here, they are all on the denominator, so you don't want any of them to be zero. And so that would be good. And this will be it. In our next video, we're going to look at how to solve absolute value equations. And it's going to be a good one. And I will see you there. Alright guys, that is it for now. The link for this note is always going to be in the description below. If you like this video, don't forget to share, like, and subscribe. Also, follow me on my other social platforms on Facebook, Instagram, Snapchat, and Twitter at Franck's Note, and I will see you in the next video.